I'm Derek Dunrankin. I am the director of the Master of Engineering program and professor of mechanical and aerospace engineering and civil and environmental engineering emeritus. So I timed my retirement just to join this wonderful program as this is a new opportunity for educational achievement for all of you students that have started this program. I hope that you felt that. I also had the pleasure of teaching one of the courses, so I could get a feel for all of what was going on in the program. So let me welcome all of the students, particularly this first M.Eng cohort, the faculty and all the faculty directors for the program and those that have taught in the courses that are here, all the industry folks that are here that have helped guide the program, and then anyone else who's just interested and maybe came across the opportunity to see what was happening in this showcase. I don't have to tell the students that you are all a very, very, very special group, because it's the inaugural cohort of the Master of Engineering program in the School of Engineering. But that wasn't enough, was it? I mean, you couldn't just be the inaugural cohort. It had to be the cohort that lived through pandemic remote instruction of the inaugural year. And so you had a double layer that I think no one will ever achieve again. So I think you can all congratulate yourselves on a remarkable and amazing achievement of just being through this program. I think that we have a great team here in the Master of Engineering program with all of the instructors in the project courses, as well as the staff with Jean and Nikki and Julia and Professor Kurdahi. We have the support of the Dean's office. So really, I think you have everything that you can expect from a school like UCI for now and on into the future. And so this is a special conclusion. This is the first annual project showcase for the Master of Engineering program. It's the culmination of all of the hard work that you've done on these projects. And as you all know, the project experience is a kind of the centerpiece that lets you see yourselves as practicing engineers and take what has been presented in courses and have that come through in delivering some kind of outcome that we've all now seen in the various projects. So I think everyone has had a chance to look at your wonderful videos and posters, and there'll be a lot of discussion going forward. So I just wanted to say, besides the welcome, that we're all hoping that this Master of Engineering makes a difference in your life. That was the point, that it makes a difference in your life. And it's not just at this moment that the difference would happen, but you should be seeing the fruits of this foundation through the rest of your career. And that's what we're hoping. I think most of you should be very much distracted by your projects. So all of these words that I'm saying, maybe they aren't going to mean anything at this moment because you're concentrating on answering the questions of what's going to happen in the breakouts. But I want you to know that we all are extremely excited to see what is the outcome of this amazing year. So let me just once again welcome you to this showcase, and we're going to hear about how that structure of that showcase works. And before that, I pass on the introductory remarks to Dean Michael Green. Thanks for being here.
Thank you, Derek, and welcome to everybody for this really momentous event. On behalf of the Samuel Lewis School of Engineering, I want to really appreciate the company liaisons from Advantech, Advantest, MerchSource, Oster Americas, US Hybrid, as well as our faculty-led projects. I really want to thank you for the liaisons for dedicating your time to our Master of Engineering students. We are truly grateful that you're committed to guiding and training the next generation of engineers. We look forward to keeping those and even deepening those relationships with our industry partners in order to make the UCI Samuel Lewis School of Engineering a top choice for earning an advanced degree. The current strategic plan for the Samuel Lewis School has an overall theme, and that is developing human connections. And we take that in all aspects, but in particular in our educational and research programs. A number of the projects represented in this showcase certainly fit in and indeed exemplify these values. But I noticed that they also directly address the challenges that we faced during this very unusual academic year. Just for a few examples, we've had projects that aim to improve indoor air quality, reduce the chance of exposure to germs on door handles and other objects. We have some other projects that deal with other aspects of human health, such as rehabilitation of joints, clinical shadowing, and even modified breathing to reduce stress and anxiety. So it's a really special group of projects that we're all here to discuss and honor. As Derek said, these were all team projects. And of course, the challenge was even greater for those teams because everybody was required to work remotely this year. And with that, I really want to congratulate all of the students for their efforts in these projects. This is an unusual year indeed. And this is a great way today to celebrate the successful conclusion of our inaugural year for the Master of Engineering program. So again, welcome everybody, congratulations. I'm going to pass it over to Vincent Farzad.
Great, thank you, Professor Dunrankin and Professor Green. Yeah, let me join in welcoming all of you to the first ever Master of Engineering project showcase. Let me also re-emphasize that the support of the sponsors is instrumental to the success of these programs. And again, I want to thank the sponsors very much for their time and effort on guiding the students and also bringing the inspiration for these projects to the teams. In this segment here, we're going to hear from the 7 project teams about the projects that they've been working on. These are the projects that we'll look at. There's 7 of them, as I mentioned. I'm Vince McDonald. I'm one of the faculty advisors, along with Dr. Farzad Amankanlu, and so we're going to introduce these different team projects. The order in which they're going to be presented is shown on the screen here. So we'll start with Advantech, go to Advantest, Merch Source, OSUR, US Hybrid, Michelle Kine's project, and Sean Young's project. And so before we start, I do want to kind of emphasize the fact that there is some unusual aspects here this year. I mean, these teams were assembled over the winter break, all right? And so the teams were formed right at the height of the pandemic, kind of right here in Orange County in California. And so these team members were asked to work together closely on these projects, but they all have complex individual schedules. Many are in different time zones, right? They're from different engineering disciplines, different cultures, and yet they're going to have to work together. There's uncertainty in the skills that are required. Sometimes there's changing requirements. And when you think about it, the goal of many of these projects is to develop a functioning prototype, right? How on earth can they do that given all of these circumstances? So it's a very challenging environment. And again, I would congratulate all of the students. You should be very proud of yourselves. I know I am of the progress that you made given this very unusual situation. So now some ground rules. These will be short 5-minute presentations, so rather quick. And so because of that, what we'll do is ask you to make notes of questions that you might have during the presentations. But then you'll have ample time after the presentations to join the teams in their breakout rooms where you can have further discussions with the team. So with that, I would like to basically get started with the project pitches. And so for that, I would like to introduce Dr. Farzad Amankanlu. He's one of the other capstone project advisors along with myself. So Farzad, if you would, can you please introduce the first project pitch?
Thank you, Professor McDonald. My pleasure. The first project is Advantech, Indoor Air Quality Improvement System. The goal is to design and test a comprehensive Internet of Things IoT product for customers to improve the indoor environment and to improve their lifestyle. So I would like first to thank Advantech team, Mr. Joe Sanga, Mr. Waylen Hong, and Mr. Joseph Su for their great support to our team and our students. We have 3 team members majoring in mechanical engineering and electrical engineering, and they have been working on this project for 2 quarters. Team Advantech, the stage is yours.
Hi, everyone. This is Team XYZ for Advantech project of Indoor Air Quality Improvement System. My name is Sun Xu, and I'm the team leader. This is software engineer Yu Feng and mechanical engineer Zhou Yuan. Welcome to our Capstone Project Showcase. I'm going to start our presentation by introducing our background scenario and how we resolve this issue. People are staying at home much longer to avoid COVID-19, so we should have more and more notice on when and how long to turn on devices such as windows, humidifier, and air purifier. However, there's no comprehensive platform or apps relating the indoor properties with air quality. This IoT project using Advantech hardware combined with different kinds of sensors and microcontrollers to get data and send to the cloud and then analyzed and illustrated back to customers as dashboard format with different suggestions and graphs. In short, this project serves as a comprehensive IoT product for customers to improve indoor environment and to improve their lifestyle. Before we dive into the block diagram in the very next slide, I would like to explain why we choose the certain sensors. Oxygen and carbon dioxide are very similar. They have a certain range limit which to keep. Otherwise, it may cause different health issues such as dizziness and exhaustion. On the other hand, PM 2.5 value is very related to an important universal scale, which is called air quality index. As is shown in the chart, we need to monitor indoor PM 2.5 value to make sure an acceptable AQI level.
As video, we collected the data from 3 different sensors and used Wise uploaded them to Azure hosting matrix collecting server. Besides, MIO can be our workstation to monitor the data by accessing the web dashboard. Moreover, we can trigger the relay from cloud. Now we dive into the sensors part first.
In our project, both temperature and humidity readings are transferred to Wise using analog signal. The Arduino output the PWM signal when it processes the sensor data. Then we use a DAC module to convert the signal into a 0 to 10 watt analog signal. Picture on the bottom left shows the dashboard of Wise input, and the right picture shows the data we collected from sensors. All sensors and the DAC modules had been calibrated to ensure a precise reading.
Now we dive into the cloud side. After we upload the data to Azure, we use Prometheus as our matrix collecting server and use Grafana as our data visualization and alerting server. Besides, once alert happens, Grafana will send a webhook to Jenkins, also hosted on Azure. Then Jenkins job will send HTTP request to Wise to trigger the relay function and open the window or air purifier.
This is an example of our dashboard illustration. All data from temperature, humidity, and PM 2.5 sensors are illustrated by a graph. As we can see, when we introduce some pollutant into the lab environment using soldering iron, the PM 2.5 value increases. However, the reading drops dramatically because the window is open. This graph only shows a short period of time, so the temperature and humidity readings are stable and do not have a large change in value. This is our window automation unit. A motor is attached to the bottom window frame and controlled by Wise from a relay and motor drive. When a certain value reaches the threshold, such as PM 2.5, the cloud will automatically trigger the Wise to open up the window.
This is our extremely lightweight of 80 grams environmental 3D printed shell. It allows the maximum airflow rate by implementing openings on each face of the hexagon, which result in total area of 130 square millimeters. In addition, special characters are embedded on the cover of the shell to make it unique.
Here is our final product requirement document. We can tell that the final product meets all nominal and most ideal requirements.
At the end, we want to further thank you all for your time listening for our presentation. And thanks for company liaisons, Mr. Joe Sanga, Mr. Weilun Hong, and Mr. Joseph Su, and Dr. Fazard for amazing support of our project. And please feel free to join us for the live demo in the breakout room by scanning the QR code right here. Thank you.
Thank you, Team XYZ and Advantech Liaisons. Great job. Yeah, please make sure to go to the breakout room and visit the Teams virtual booth for the live demo. They are going to have live demo every 15 or 20 minutes. This is going to be after we are done with the project pitch session. And now back to my colleague, Professor McDonough.
Thank you, Dr. Aman Kanlu. The next project is from Merch Source. And the idea of this project is inspired directly from the COVID situation, where we want to try to reduce transmission of germs and viruses. So the idea of this project was to develop an innovative, durable system to essentially self-clean itself as a doorknob. And so a pretty interesting project proposition. And the idea for this is to try to develop a product that Sharper Image can then market, right? Sharper Image is one of the brands that's under Merch Source. The sponsors of the project are Pip Tompkin, Adam Grompton, Keith Covey, and Adam Spiglia. And the team has 4 members, 2 from mechanical and aerospace engineering, 2 from electrical engineering and computer science. So Team Merch Source, the stage is yours.
Hi, everyone. Welcome to Showcase event at UCI 2021. We are a Mersource team. I'm Long. I'm a mechanical engineer from UCI.
Hi, I'm Khaled. I'm a mechanical engineer from Dubai, UAE.
Hi, I'm Yuan Liu, an electrical engineer from Nanchang, China.
Hi, I'm Huang, an electrical engineer from China.
So our design motivation, as you know, door handle is one of the most touched components in public places that can transfer the virus from one to another. So our mission is to design the door handle with UVC light technology that can kill and prevent the spreading of the virus and bacteria in public places. Our products are going to use kinetic energy when you opening and closing the door to rotate the gear system and the bell. So our products come with different mechanical and electrical parts. To learn more about the system, how the system works, what the difference between the parts, I pass to my teammate Khaled. He's going to explain more about the system.
Hi. So out of the tens of components, one of the fundamental mechanical components of the product are the gears. So 3 gears having gear ratio of 1 to 10 are responsible for transferring kinetic energy from humans to the belt. And we wanted our product to be as self-sustaining as possible. So the principles of dynamics were used to design the gears so that the 60-degree tilt from the door handle would cause a 360-degree in the last gear and moving 22 centimeters of belt length by doing so. So for the power balance, we have electrical and kinetic components. So the electrical components of the power end, we have 5 AA batteries with 15.6 watts and indoor solar panels that can provide an estimate of 10 to 30% of the required energy. On the outside, we have 4 UVC lights with 5.8 watts of power and a microcontroller that when in on mode will consume 30 milliwatts. For the kinetic energy part, which is fully sustainable, we have a human hand, of course, which can comfortably apply 90 newtons downward force, which is 7.78 Newton meters of torque with our door handle and equivalent to 10.2 watts. This is responsible for repositioning the door handle and also causing the motion of the gears and the belt. And this design, with the current design, we can reach up to 3,000 cycles before the need of replacing the batteries.
So the USLI part is a very critical part of our design. Here we use 4 USLIs arranged evenly to cover a larger area and to achieve the better effect to disinfect the build. The 4 indicators we choose these USLIs are illuminance, light emitting angle, energy consumption, and their size. And of course, for the builds that would be exposed to the UV light for a very long time, we also consider about whether they are resistant to this UVC light. Here in this slide, we can see we listed the both required for the disinfection and our calculation about these statistics. And according to our calculation, use our design, we can finish the disinfection in just 5 seconds.
The electrical systems we designed mainly consists of 4 parts: the tilt switch sensor circuit, the relay control circuit, the battery level indicator circuit, and the indicator LED circuit. When our door handle gets pushed, the microcontroller will just sense the change of the tilt switch, and then lighten the UVC LED by the relay for 5 seconds. After 5 seconds, the UVC LED will be off, and the battery level indicator circuit start to measure the voltage of the battery group. If the battery is running out, the indicator LED will be on and off to inform users.
So for the summarized results of the product development, we were able to successfully test all the mechanical and electrical components. For the mechanical components, we had a successful gear rotation. The door handle and the spire spool worked together with repositioning the door handle. We had a smooth belt motion with no belt stress problems, which was kind of hard to deal with. And for electrical components, the UVC lights triggering and timing worked successfully. So was the battery level indicator. So thank you guys for joining us, and we'll be waiting for you in the groups. Thanks.
Thank you very much, Team Merch Source, and thank you very much for the liaisons from Merch Source. Great job, great job. Okay, next up is Team Osur Americas, and the idea that they were presented with was to develop a device to help patients do physical therapy rehabilitation exercises, which is something that none of us like to do, I don't think, right? So but the idea was to facilitate having these exercises done correctly, but to do them at home, right? So that's the hard place to do the rehab. We had a great sponsor in Jared Olivo from Osur. There were 4 team members on the team Osur, 2 with mechanical and aerospace engineering background, 1 with biomedical engineering background, and 1 with electrical engineering and computer science background. So highly multidisciplinary. So with that, let me turn it over to Team Osur to describe their project.
Hi everybody, welcome to our project, Wireless Smart Non-Orthotics, sponsored by Osur. My name is Edgar Chin. I'm the team leader for this project.
And my name is Jiexuan He.
Hi, this is Mabanu Iranzamini.
Hello everyone, my name is Emil.
So to start off, I want to discuss the need for this product. Each year, an estimated 2.5 million injuries were reported to making it by far the most commonly injured joint. According to the charts you see on the screen, people between the ages of 15 to 24 years old suffer from injuries. Likely because that is the period of time when we are the most adventurous and athletic. Finally, this goes without saying, but with COVID-19 affecting our lives the way that it has, the need for a way for people to heal their injuries remotely and at home is even greater.
And because the majority of people with sustained knee injuries are high school and college athletes, and we expect schools and universities to be our main demographic. And the athletes will be required advice from their PT and athletic trainers, who will be monitoring their patients throughout their rehab.
Our original plan was to create an orthotic solution geared towards women as their primary demographic. We felt that the disproportionate rate at which females got knee injuries justified our choice. But with our device, we wanted to monitor our users' rehab progression by recording important exercise variables, like squat depth, number of reps, and also warn them of poor exercise form. The idea was to remotely provide our users' physical trainers with enough information to make judgments on their patients' rehab. However, we found that the orthotic solution was pretty cumbersome and easily slipped off, making measurements pretty inconsistent. The solution to that would be to just stick them onto a leg like a decal, but that would be pretty annoying for our users, honestly. On top of that, there were already so many products in the market, like the ones you see on the screen. Our device on the bottom right probably wouldn't have been able to. So instead of going with that route, we decided to go with a completely independent camera system called the Azure Connect. The If you're familiar with Microsoft's Xbox Connect, the Connect is a bit of a spiritual successor to that, designed primarily for medical purposes. It features a more powerful depth sensor that allows us to get accurate measurements of body movement throughout the day. And we felt it was the perfect way to create an uninvasive product to monitor rehab progression. We would love to show you guys a live demo of this in action, but for the sake of time, you guys can catch that in our breakout room later.
Our main focus is to make the application more user-friendly and easy to use. The user will first sign up and create a profile. Next, the patient will select the preferred exercises and perform their set. If the user did the exercises incorrectly, the application will notify them and stop the count. And if he did it correctly, the user will get the progress results. All the data will be stored on the cloud, so the user and their PT physical therapies will be able to see and analyze it.
We initially spent some time on researching and finding the unmet need and also studied our market. And by the end of first quarter, we used design down selection analysis to find our best solution for a non-contact body tracking to monitor patients' rehab progression and guide them through their prescribed exercises. Here you can see for the device validation, we use goniometer, which is currently used device by physicians as a standard form of measuring knee angles.
As for our future plans, we wanted to improve our user interface and the app our device is hosted on. We also wanted to shift from a web-based app to a native app so users could take this device on the go and not have to rely on an internet connection. Next, in the spirit of our generation and our love for smartphones, we also wanted to create a mobile app to make operating the device more convenient for our users during exercise. Finally, and most importantly, we want to include more measurable variables because more information is always beneficial to our users. These are references for all the charts that we used in this presentation, and thank you for listening.
Thank you very much, team. And again, appreciation expressed to OSUR Americas for their support and guidance on this great project. Thank you. Okay, I'm going to turn it back over to Dr. Aman Kanlu, who will introduce the next set of projects.
Thank you, Professor McDonald. And next, we have a faculty-led project from Dr. Michelle Kine. The title is Virtual Reality-Based Clinical Shadowing. The goal of this project is to develop an easily accessible and useful library of virtual reality videos for students and professionals to use in order to supplement or satisfy needs that would typically be met through in-person clinical settings. Dr. Christine King and Dr. Michelle Kine are the faculty mentors on this project. And we have had two great team members, both majoring in biomedical engineering and team VR clinical shadowing. The stage is yours.
Thank you, Dr. Moncalli, for that introduction. So we are virtual reality-based clinical shadowing with the UCI School of Medicine and the School of Engineering. I'm Tyler Gordon.
I'm Kiali Akbar.
Our liaisons and faculty are Dr. Christine King and Dr. Michelle Kine, and our faculty advisor is Dr. Farzad Alman-Kalman. So why are we here?
Great question, Tyler. So here's the problem. The COVID-19 pandemic has been a wake-up call in so many different ways. And one thing in particular was access to clinical health settings. Of course, hospitals were very strict on who can come in and come out, but the issue of clinical access, whether in the hospital or outpatient, has been present both before the pandemic and will continue to persist going forward. So in speaking with pre-health students, medical students, biomedical engineers, and physicians, we learned that in-person clinical experiences are both crucial and hard to come by. And while it's never going to be a direct replacement for the real thing, that virtual reality can be a good supplement for these groups. Now, at the moment, there are a few experimental attempts to bring VR and health scientists together, namely a startup out of USC called GibLib, who focuses their VR videos on complex specialized procedures. But there's still a lack of access to those sort of bread and butter procedures and operations that physicians perform on the regular. And so, of course, that begs the question, well, what are we going to do about it? So Tyler and I set out to create a easily accessible and useful library of virtual reality videos for students and professionals to use in order to supplement or satisfy needs that would typically be met through in-person clinical settings. And that includes supplemental materials for health professions training, clinical needs finding for biomedical engineers, patient education before procedures, and potentially more down the line. And so all that brings us to the following. So this is an example of a video that was put together by a team. It's a colonoscopy that we filmed in conjunction with Dr. Steve Mills at the UCI School of Medicine. And so what you can see here is that we're currently in the third person 360 view perspective. And you can, of course, pop on a Google Cardboard or an Oculus and look around here. Now, in addition to that, we have a first person camera, which is typically worn by the physician, and that focuses on the hands of the physician. And that's the view that's floating above the screen there at the top. And then depending on the nature of the procedure that's going on, we may additionally add like an auxiliary video. That could be an endoscope or laparoscopic video or microscope video, whatever it may be. But altogether, we combine these things into these virtual reality experiences, so to speak, one of which you can see right here.
So let's get into the product. If you go to ucivr.com, you could click on our demo video. Here's an EEG. Here, you could see the 3 videos that Kia mentioned. We have the first person video, third person video auxiliary. You could look around in your VR headset. You can see what's going on. Down you scroll, you see browse library, and a bridged version of our value proposition. We'll browse the library in a second. And you can see we have many different specialties and a real life alternative. And so if you click on browse library, we have 6 different specialties at the moment, which we're looking to grow. But let's say you want to click on colon and rectal surgery, and you can see that colonoscopy video that Kia was talking about. And you could look around and you could see all the technology. You could see the nurses, physicians, that auxiliary video, third person and first person video. But let's say you wanted to look at some other videos. You can also see ophthalmology, urology, simulated care, physical therapy. And for instance, let's say we wanted to click on an EEG video. Here we have 4 EEG videos to look at. And we have those 3 different camera perspectives I was talking about. If you have any questions or concerns, you could contact our PI, Dr. Christine King, whether emailing directly, or if you don't want to email directly, just put your email on our product here. And you could contact our PI through the app, through the website, and we'll get back to you as soon as possible. We also do have a back-end payment system. It's currently at $5 per year. However, we don't have enough content yet to really be selling the product. So currently everything's accessible, but once we're done, once we create more content, then we will start monetizing. I'm going to talk about commercialization more right now. So some things for future work. So one, user trials. We want to grow and give people more access to the database and get more feedback. And see what people like and what people don't like. Next, commercialization. So in addition to our subscription service on our website, we want to license to different universities so that more students can have access to a virtual shadowing setting. Thirdly, and I mentioned this earlier, building up that library content. We have 6 specialties right now, but really what we want to be doing is have more content, have more specialties, and really have something that can really compete with Giblib, because what makes them so competitive in the market is that they have so much content right now. And last 2 are experimenting with augmented reality. So rather than going on the website, we want you to be able to put on your VR headset, look around, and interact with your arms or eyes with the product rather than clicking around. And then finally creating a platform for Oculus. So it's compatible with Google Cardboard, which is this right here, but Oculus, we're having some problems. So that's it. Thank you. Questions, comments, concerns, please join us in the breakout room. And if you want to use this QR code, you could go to our website at www.ucivr.com. The QR code will take you there, and let's talk about virtual reality in a clinical setting. Thank you.
Good job, team. Thank you, Tyler. Thank you, Kia.
Yes, nice headset.
That was good.
#1 fan.
Yeah, thank you, team VR clinical shadowing. Good job. And thank you, Dr. King and Dr. Kai for mentoring the team. And we are going to have our last, but not least, project pitch. This is the other faculty-led project from Dr. Sean Young with the School of Medicine. The title is Compact Breathing Device to Unconsciously Combat Stress and Anxiety. The project's focus was to research the mechanisms and benefits of deep breathing and design a product that reinforces it. 5 team members majoring in mechanical engineering, electrical engineering, biomedical engineering have been working on this project. Before the team starts, I would like to mention that they can only present around 5% of their work in the showcase. This is due to the confidentiality of the material they have been working on. Team compact breathing device, please pitch your nice project.
Hello, everyone. My name is Snow Liu, and I am joined here by my 4 teammates.
Hello, everyone. I'm Bernardo Perez.
Hello, everyone. I'm Zekai Wei.
Hello, I'm Angad Singh.
Hi, I'm Hao Sung Wang.
And together, we are here to introduce to you our work during the past 6 months on the compact breathing device. Before we start, let's take a look at this short clip.
I have thou forsaken me, O deity whose existence I doubt.
Here, read into this bag.
What's going on? They stole everything, Leonard. Everything.
Are you the roommate?
Yeah, Leonard Hofstetter. What happened?
Your friend here called 911 to report a robbery.
Oh my God, what did they get? What didn't they get? I got my enchanted weapons, my vicious gladiator armor, my wand of untainted power, and all my gold. You called the police because someone hacked your World of Warcraft account?
We just witnessed the brilliant Sheldon Cooper suffer from an anxiety attack and hyperventilate. The solution to this was to breathe into a paper bag and to help control his breathing. My question is, why are we still using such an ancient technique? Sure, it works, but who in their right mind carries a paper bag with them at all times? There are so many benefits to deep breathing. Our goal is to design, build, and test a product that will encourage users to incorporate deep breathing into their daily lives.
In the beginning of the project, we all were tasked with researching and incorporating deep breathing into our everyday activities. While some of us were skeptical of the validity of claimed benefits found in the research papers, we quickly realized that there are indeed many upsides to deep breathing. The first thing we all noticed was that it could trigger a calm response, which also aided in helping people to fall asleep quicker. Research showed that the deep breathing could boost the immune and the digestive system health. It also could lower blood pressure and lower elevated heart rate. It could make people more immersed and focused when completing activities. Last but not least, it allows people to relieve stress and reset their state of mind.
In order to gauge the market, our group conducted product research of existing breathing devices advertised to help with deep breathing reinforcement. We identified 6 different products available, and 3 of them in particular stood out to us, those being the Shift, the Breather, and the Be Calm. But all of them have their pain points, making them less than ideal products. For example, the Shift, while it has a compact and sleek overall design, it has a high price point of $105. The Breather was designed for breathing reinforcement, but it has a very large, bulky, and bulbous overall design. And there's also the Be Calm, which is advertised to be small and disposable, but its form factor is not very appealing. With all these elements in mind, our group set out to design, build, and test a compact breathing device that excels in all of our design criteria where our competitors falter.
It has been a productive and eventful 2 quarters working on the compact breathing device. As much as we would like to share specific information regarding simulations, engineering design, and prototypes that we created, due to our sponsors' request, we will not be disclosing the explicit details of the project.
Over the course of 22 weeks, we came up with 23 different SolidWorks designs. Of these 23 designs, we simulated 15 using computational fluid dynamic software plugins in SolidWorks. Although we 3D printed 21 different prototypes, only 15 of them needed CFD simulations because some of the prototypes had very small changes to them. From these 21 prototypes, we were able to conduct 4 airflow sensor tests and compare them with the CFD simulations of the same prototypes. Through testing and observation, we found that the actual airflow velocities were in tune with the airflow velocities from our SolidWorks simulations. For the purposes of the project and proof of concept, we created 4 motion studies in SolidWorks to display how the designs would work in a real-world environment.
Thank you for joining us today. We wish we could have shared more with you. Hopefully we encouraged you to incorporate some deep breathing into your daily routine, and we look forward to seeing you in our breakout room.
Thank you very much, team. Compact breathing device, great work. Thank you. And thank you very much, Dr. Young. So this was the end of project pitch session. And once again, I would like to thank all the students for their great work and all the wonderful sponsors for their great support for our students and to our students.